Anyway, so let's start now. Today, inshallah, we are going to start probability. Okay. Now, probability, just to let you guys know that we have many different types of probability in S1. Okay, so we have the normal probability, we have conditional probability, we have binomial distribution, which we use to find probability. Just like that, we have geometric distribution, which we use to find probability. Just like that, we also have normal distribution, which we use to find probability. Okay, so today what we're going to do is we're going to do the very basic element of probability, which is very similar to, not very similar, but yeah, kind of like what you guys did in O levels as well. Okay, so I will be doing a recap. Obviously, I'm not gonna just assume that you guys know everything already. I will be doing a recap. So you will notice that the questions are slightly more complex compared to the ones that we used to have in O levels. Okay. So like I said, we have normal probability, normal in the sense like regular. Okay. This is not a technical word term or something. Okay. Similar to O levels and IGCSE. And then we have conditional probability. Have you guys heard of conditional probability? Have you guys done it already? Khair, like I said, I'm not exactly relying on that you guys have done it. Okay, we're gonna be doing it from scratch anyway. So, what exactly is probability? Okay, let's start from the very basics. What is probability? Probability is basically the chance of an occurrence of an event. Okay, so probability in short is basically the chance of an occurrence of an event. Okay, how do we express probability? It's expressed as decimal, fraction, or percentage. Okay, so it can be expressed as a fraction, number one. Number two, it can be expressed as a decimal. And number three, it can also be expressed as a percentage. Okay, and if you have it in percentage, you can always convert it into fraction form. You can always convert it into decimal form. Yes, we are starting a new chapter, Mikhail. Okay, now what exactly is the formula for probability? The very basic formula. I'm not asking for the complicated one. The very basic formula is that probability is basically equal to the number of favorable outcomes, okay, divided by the number of total outcomes. Yeah, favorable upon total. Okay. Now, just to do a quick recap of, because this is something that you guys have already done in O levels. If let's say we have an MCQ, okay, with four answer options A, B, C, D. Now, what's the probability of getting a question right? What is the probability of getting an MCQ at random, right? And that is 1 upon 4. What is the probability of getting it wrong? 3 upon 4. That's correct. Now, in case anyone who's wondering, although I really hope not, but in case anyone who's wondering why the probability of getting it right is 1 upon 4, because there is only one correct answer of the 4. Just like that, there are 3 wrong answers of the 4. So, favorable upon total. Okay. Then let's say you roll a die. Okay. Now, in O levels, usually all the dice and all the coins that we used to deal with used to be unbiased. Okay. So if let's say you roll an unbiased die, then what is the probability of landing a 6? What is the probability of getting a 6 on an unbiased die? Sorry, 1 upon 6. That's correct. Good job. Okay. And what's the probability of getting any number? In fact, if you think about it, it is 1 upon 6 throughout. Okay. Why? Because it's an unbiased die. Because it's an unbiased die, that means all the probabilities are going to be equal. Okay. So make sure that you watch out for these two words, one of the two. So the question can say that it's unbiased. And if it's unbiased, that means equal probability. Okay. Or the question could say that it's biased. Biased means that it's favoring one side or a set of sides more than the other. Okay. So whenever the question says unbiased, it will not give you the probability of every single outcome, because we know that it can be calculated by taking the total divided by the number of outcomes. Okay, probability. But when the question says biased, that means unequal probability. Now you can't really say for sure what the probability is going to be when it's unbiased, which is why the question will give you the probability. Maybe it will give you the probability of one and not the other, which you can find out by subtracting from one, which brings me to a very important key point, and that is, what is the sum of probability? Sum of probability or total probability is always equal to what? 1. That's correct. Sum of all, or sum of probability, or we can say the total probability, is 1. Okay. Now, if you know the probability of losing, okay, suppose that there are only 2 outcomes. Okay, so how can we work out the probability of winning? It's going to be 1 minus the probability of losing. Okay, and this principle can be extended to not just winning and losing. In fact, you can extend it to pretty much anything. So if, let's say, you want to find out the probability that an event does not occur, okay, then what do? You do 1 minus the probability that an event does occur. Okay, so A is basically the probability of the event occurring, and A prime is basically the probability of an event not occurring. So if, let's say, you have the probability of winning, you can find out the probability of not winning, which can include losing or draw, whatever, but you can do that by simply subtracting from 1. Okay. Now, a couple of, again, things to remember back from O levels. If we have the word and, or if we see the word both, what do we do to the probabilities? We multiply. That's correct. Okay. If we have the word or, in that case, what do? We add. Okay. If we have the word or, okay, in that case, we add. Achha, not just that. There's another thing that you guys need to remember, and that is, whenever there are multiple ways, of fulfilling the same condition. So whenever there are multiple ways of fulfilling the same condition, okay, and this usually happens when order is not given. Okay, let's write that down in bracket. Usually happens when order is not specified. What do we do then? We find the probabilities of all possible orders and add them up. Now, I'll give you an example. If the question says that one is red and the other is blue, okay, so for example, if the question says that one is red and the other is blue, find the probability that one is red and other is blue. So notice what the question has done. And let's say we're talking about cards, we're talking about whatever we're talking about, that's not important. The question has not specified as to which should be red and which should be blue. So what do we do in this case? In this case, we consider the order red, blue, okay, or we consider the order blue, red. Okay, so that's what we do. We find the probabilities of all the possible orders and then we add them up. Okay. Now, this was just like a recap or a summary of the theory of probability. If you have any questions so far, please go ahead. If not, then we're going to move on.
So, could you please explain the last point again?
The one is red and the other is blue? Okay, dekho. If the question does not give you the order in which a certain event has to happen, okay? So in that case, what do? We consider all possible orders and then we add them up. Like, for example, let's say you're giving 2 subjects, okay? Yes, I'll explain biased and unbiased again, don't worry. So let's say you're giving 2 subjects, okay? One is math, the other is English, hypothetically speaking. Now, let's say I say that the condition, or find the probability that you pass one subject and fail the other. Now, in how many ways can you fulfill this condition? Think about it. In how many ways can you fulfill this condition that you pass one and fail the other? 2 ways. Okay, what are those 2 ways? That you pass math, fail in English, you fail math, pass in English. Okay, yeah, exactly. Fail, pass, fail. So, what are you going to do now? You're going to calculate the probability of passing math, failing in English. You're going to calculate the probability of failing math, passing in English, and you're going to add these probabilities. Yes, exactly. Okay, so that's what the last point is. Does it make sense now?
Yes, sir. Thank you.
Okay, great. Now, unbiased and biased. So I'll explain what this means. Unbiased means that it is all the probabilities are equal. Okay, so if let's say I have an unbiased coin, that means a coin has how many sides? 2 sides. So that means there's a 50% chance of landing on heads and there's a 50% chance on landing on tails. Okay, because it's a fair coin. So look for words like unbiased or fair. If the question says biased, that means maybe it's favoring one side more than the other. In that case, maybe, okay? We can't say for sure. The question will tell us. Maybe the probability of getting a heads is more than the probability of getting a tail. So the question might say that you have a biased die such that the probability of getting a heads is 0.7. So now we can find out the probability of getting a tails, which is going to be 1 minus 0.7, that's 0.3. Okay, so who asked me this? Wijdan and Laiba. Does that make sense? Okay, you're welcome. All right, now then we have something which is called probability distribution, possible diagrams, and sample spacing. Have you guys heard of this before? Sample spacing, I'm sure you guys might have heard back in O levels. Yeah, possibility diagram basically. Now, how does this work? Here, let's read this. If we need to find the sum, product, or difference of 2 things in order to calculate their probabilities, we have to draw a probability distribution diagram, also known as sample spacing. Okay, so let's learn this with the help of a question. Okay. Acha, a couple of things to keep in mind is that if the question is silent, in the sense that if the question does not specify whether it's a fair die or an unfair die, okay, if the question doesn't specify, we assume, or it's an unwritten rule, that we take it to be a fair die, in the sense that we take it as an unbiased die, meaning all the probabilities are going to be equal. Okay, so let's solve this question. 2 dice are rolled and their sum is recorded. Find the probability that the score is a perfect square, a prime number, the difference between the 2 scores is 5. So there are 3 parts, and all the 3 parts we can do very easily if we do something called sample spacing. Okay, now what are we doing with the score? We are recording the sum. Okay, so we have 2 dice and we're recording the sum. So here's what I'm going to do. I'm going to write all the numbers horizontally first of, let's say, 1 die, and then I will write all the numbers vertically of the other die. Okay, and here I will just write sum. Okay, now remember, this diagram is for you. Okay, this diagram will help you see the total number of outcomes, and it will also help you see all the different outcomes. Okay, which will then help us in solving part A, B, and C. So what are we recording? We're recording their sum. So first, let's add all these numbers. So we get 2, 3, 4, 5, 6, 7, 3, 4, 5, 6, 7, 8, 4, 5, 6, 7, 8, 9, 5, 6, 7, 8, 9, 10, 6, 7, 8, 9, 10, 11, 7, 8, 9, 10, 11, 12. Okay, now that we have all the outcomes, by the way, what will be the total possible outcomes here? What will be the total possible outcomes over here? 36. No, why 4? 36 outcomes. Okay. How did you work out 36? 6 into 6, that's correct. Okay. So now the question says find the probability that the score is a perfect square. So let's circle all the perfect squares, okay? So how many perfect squares do we have? I hope everyone knows the perfect, all perfect squares. So 4 is a perfect square. And how many 4s do we have? We have 3 4s, okay? And then what else? So 3, in fact, let me just highlight, all right? 1, 2, 3. And 9 is a perfect square. So 7, 8, 9, 10. Okay, and what else? What else is a perfect square? Let's see. That's it. No other one. Okay, we don't have one. Where do we have one? It's not possible to get the sum as one. Okay, so what's the answer? The answer is going to be 7 over 36. Why 7 over 36? Because 7 are your favorable outcomes, 36 are your total outcomes. Okay, now quickly solve part B, prime number. Now, how many prime numbers do we have? Or in fact, what are prime numbers? What are prime numbers? Anyone who'd like to tell me what prime numbers are? Yeah, multiple of 1 in itself. Okay, I'm just gonna erase the part that I've highlighted so we can, oops, sorry, let me just write them again. 4 4 4. Okay, 11. No, I think it's got to be more than 11. All right, now let's highlight all the prime numbers. So 2 is a prime number. Yeah, I think 15 over 36 is the correct answer, but let's just double check. 2 is a prime number, 3 is a prime number, 5 is a prime number, 7 is a prime number. 3 5 7. 5 7. 9 is not a prime number. Okay, 5 7. That's it. 7 11. 7 11. Now let's count. 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15. Yes, 15. Okay, I'm just going to quickly erase what I've highlighted so we can highlight in the next part as well without getting confused. So 15 upon 36, you can simplify it as well. Beta, where is 1? Fatma, where is the sum 1? Exactly, there's no 1 in the table. Okay, and 1 is also not a prime number, just so you know. Okay, now let's do part C. Part C says the difference between the two scores. No, it's not a prime number. 1 is not a prime number. Okay. The difference between the two scores is 5. So here we have all the numbers where all the outcomes where the difference is 5. Okay. Acha, oh, wait a minute. It says the difference is 5. Sorry. Okay. So now, can we use this diagram? I thought it said the sum. Okay. No, we are going to subtract. Acha, here's the thing. Now, you don't have to redraw the entire diagram. Okay, you don't have to redraw the entire diagram. What you can do is you can just focus on what is the favorable outcome, okay, and just circle those. You know the total possible outcomes are going to be 36, okay? Now, when is the difference going to be 5? When one score is 6 and the other is 1, okay? And there's another possibility as well. When one score is 6 and the other is 1. No, 7 minus 2. Okay, is that possible? 7 minus 2? In a regular or in a fair die, do we have 7? We don't. Okay, we don't have 7 in a die. We have from 1 to 6. Remember, it's a cube in shape, and how many faces does a cube have? It has 6 faces. Okay, or if you've ever played Ludo, you would know, or any other game which involves the use of dice, you would know exactly what I'm talking about, right? So what are the favorable outcomes? The favorable outcomes are 2. What are the total outcomes? The total outcomes are 36. So you can simplify it or you can leave it as it is. Doesn't matter. Make sure to read the question carefully, okay? So there you go. That's the answer to this question. If you have any questions, feel free to ask. If not, yes, I can explain again. So part C says the difference between the two scores is 5. That means we're looking for two numbers such that if we take out their difference, it's 5, okay? So if I get 1 on one die, what should I get on the other so that the difference is 5? 6. Why? Because 6 minus 1 is 5. Okay. Now, if I get 2 on one die, what should I get on the other? I should get 7. But is that possible? No, that's not possible. Just like that, you can't get 3 and expect any other score to be such that the difference is 5. Same goes for 4, same goes for 5. But if you get 6, then if you get 1 on the other die, in that case, the difference is going to be what? The difference is going to be 5. So what are our favorable outcomes? We have two favorable outcomes from a total of 36. So 2 upon 36 is the answer. Okay? Does that make sense? Okay. Now let's do another question. Another thing that I want to revise is a tree diagram. Okay. Okay. So this is a very extensive question which we're going to solve. Okay, we're going to solve it together, and this will serve as a refresher of tree diagram. Tree diagrams are also basically help us to show all the possibilities. Okay, so tree diagram is also another form of a possibility diagram. Okay, any diagram that helps you see all the possibilities is a possibility diagram. Okay, what's the difference? No, there's no difference. It depends on the kind of event that you're dealing with. Okay, so since in this case the one thing that makes the most sense is a tree diagram. So whenever you have to take the sum or the difference or you have to do any arithmetic operation, we prefer something like this. Okay. Now, let's read the question and see what it says. Acha, by the way, I hope everyone understands what without replacement means. What does it mean, without replacement? In simple terms. Total doesn't change. Total does change. Without replacement means that the total will change. Yeah. Yeah. So that means if you've taken one blue, now you have 3 blue left. If you've taken one green, now you have 2 green left. Okay? So the total will change, all right? Keep that in mind. Without replacement means that the total will change. Okay, now. Acha, okay, wait a minute. Sorry, I think I know why you guys are getting confused. This is not the question to go with this example. This is the question to go with this example. Just a minute. Yeah, the question said with replacement. I think that's why you guys got confused. Just a minute. Okay, now. So let's once again read what this question says before we start solving it. A bag contains 5 red, 2 blue, and 3 green balls. 2 balls are chosen at random without replacement. Now, without replacement means that once you take it out, you look at the color, you don't put it back into the bag. Okay? So you take it out, you look at the color, you don't put it back into the bag. Okay? You keep it on the side or whatever. So that means now, if let's say you had 10 to begin with, now you have 9 in the second attempt. So if in the first attempt you had 10 total outcomes or 10 total balls or marbles, whatever, now in the second try or in the second time that you're taking it out, you have 9. Okay? All right. Now, first of all, before we start solving this, let's make a tree diagram. Okay? Let's make a tree diagram to represent what's going on in the question. So how many different colors do we have? We have red, blue, and green. So that means the tree diagram that I'm making for the first attempt, or you can say for the first time that we're drawing means that we're taking out, our tree diagram will have how many branches? It will have 3 branches. Okay, one for each color. So one for blue, one for red, blue, and green. Okay, so let me use a neutral color. Yeah, blue, red, blue, green. Let's go in the same order. Red, blue, green. Okay, let's not worry about what the final answer is. Let's just recap how to make a tree diagram, and then we'll see what the final answer is. Okay. Now, what's the probability of drawing a red marble in the first attempt? It's going to be 5 upon 10. Why 5 upon 10? Because you have 5 red and 10 total. What is the probability of drawing a blue marble? That's going to be 2 upon 10. What's the probability of drawing a green marble in the first attempt? That's going to be 3 upon 10. Okay. All right. Now, for the second attempt, when we're making a branch in front of red, what are we assuming? We're assuming that the first is red. Okay, so if the first is red, what will be the probabilities of the second outcome? Let's see. Yes, it's going to be 4 upon 9. Why 4 upon 9? Because we decrease red by 1. So you had 5 to begin with. Now you've taken 1 out. That means now you have 4 red left. And what about the total? The total will obviously also decrease. As far as blue is concerned, the number of blue marbles remain the same, but the total decreases. Okay. Then as far as green is concerned, the number of green marbles again remains the same, but the total goes down by 1. Okay. Now, that was if the first turned out to be red. But what if the first turned out to be blue? Now, here's a suggestion. The suggestion is that always fill the same color first. So if it's blue, then fill the blue one first. So if the first one turns out to be blue, What is the probability of the next one to be blue as well? That's going to be 1 upon 9. Okay. Then the number of red marbles remain the same, but the total goes down by 1. Just like that, the number of green marbles remains the same, the total goes down by 1. And just to give you guys a simple trick, the sum of all these probabilities should be 1. If it's not, that means you've done something wrong. Okay. Acha. That was if the first one turned out to be blue, but it's also possible that the first one, instead of blue, turns out to be green. In that case, what do? This second one turning out to be blue will have a probability of 2 upon 9. Okay. Then the second one also turning out to be blue will have a probability of 2 upon 9 as well. Then the probability of red will be 5 over 9. Again, you can sum it up. 5 plus 2 is 7, 7 plus 2 is 9, so 9 upon 9, that's correct. Okay. Once you've made the tree diagram correctly, then from that point onwards, it's very likely that you're going to do everything else correctly as well. Okay, so let's start with the first part. The first ball is blue. Okay, what is the probability that the first one is blue? That's 2 upon 10. Okay, that's it. Job done. Both balls are red. So that means red, red. Now, what's the probability of getting red in the first attempt? 5 upon 10. What's the probability of, no, not red plus red, red into red. Whenever the question says both or whenever the question says and, let me add, yeah, we multiply, okay? So 5 upon 10 into 4 upon 9. If you simplify and give the final answer, you get 2 upon 9, okay? Now part C. First is red and the second is green. Yes, both is also multiply. First is red and the second is green. So that means we are not only given the color, but we're also given the order in which they should occur. So what's the probability of getting a red in the first attempt? That's 5 upon 10. What's the probability of getting a green in the second attempt? So red into green. That's going to be 3 upon 9. Simplify and get your answer, which is going to be 1 upon 6. Okay. Now let's do part D. Part D says one is red and the other is green. Now tell me the difference between part C and part D. Tell me what is the difference between part C and part D? Or do you say there is no difference? Order, exactly. So here we add all the possible orders. Okay, we consider all the possible orders, find their probability, and then add it. So one is red and the other is green can happen in such a way that first is red and the second is green, or it's also possible that the first is green and the second is red, because the question didn't specify. The question didn't say, like it did in the previous part, which one should be which. So red green, we've already worked out the probability of red green, that's 1 upon 6. Okay, then you can work out the probability of green red, which is going to be 3 upon 10 into 5 upon 9, which is also going to be 1 upon 6. Now if you add, what do you get? You get 1 upon 6 plus 1 upon 6, which is equal to 2 upon 6, which is equal to 1 upon 3. Okay. Remember what I said at the very beginning of S1, make sure that you use your calculator exactly how it's meant to be, so that not only you save time, but you also end up with the correct answer. Okay. Now let's do part E. Tell me how many ways can we fulfill this condition? 3 ways. Okay, what are those 3 ways? That's correct. Red, red, or green, green, or blue, blue. Okay. So this is what we're going to do in part E. In part E, we need to find out the probability that both are red. We need to find out the probability that both are blue. Or we need to find out the probability that both are green. Now, thankfully, we've already worked out the probability that both are red. That's 2 upon 9. Now, let's work out the probability that both are blue. That's going to be 2 upon 10 into 1 upon 9. 2 upon 10 into 1 upon 9. Let's make a bracket over here. Then let's work out the probability that both are green. That's going to be 3 upon 10 into 2 upon 9. Okay. Now, what do? 2 upon 9 plus 2 upon, or let's just use our calculator over here and get the final answer. Okay, if you do that, here's what you get. You get 14 over 45. Okay, the final answer is 14 over 45. Okay, now tell me, how will we do part F? That is correct. We subtract the probability of same color from 1, or we can do like you said. We can either do it manually, that is, we work out red, blue, red, green, then we work out blue, red, blue, green, then we work out green, red, green, blue. Okay, we will get the correct answer, but that's a very lengthy way of doing it. Okay, a shorter way would be, since we've already worked out the probability that both are of the same color, what will be the opposite of that? What will be the opposite of both are of the same color, both are of different colors? Okay, so here we can use this rule. We can use this concept here, that if you have the probability of an event occurring, then you can find the probability of the same event not occurring by simply subtracting from 1. So here's what we're going to do for part F. For part F, the probability of different will be equal to 1 minus the probability of same. Okay, so the probability of different is now equal to 1 minus 14 over 45, and just use your calculator over here. You get 31 over 45 as your answer. Okay. Now, let me know if you have any questions. Okay, great. Now, here's what we're going to do. We're going to do some past paper questions on the side as well. Yeah, so you have a certain portion of probability in AS, which is very similar to O-level probability. Okay, it's a very small portion, but it's there. Okay, so here's a question, and this is fairly, well, not too recent, but yeah, not very old as well. It's May, June 2017. Okay, so it's fairly, it's relevant basically. Okay, now let's see what this says. A biased die. Oh, so what's the keyword over here? The keyword is biased. Biased means that now the probabilities will not be the same. Okay, so if it's numbered from 1 to 6, chances are that 1 has a different probability, 2 has a different, 3. Chances are all of them are different, or maybe some of them are equal to so and so, and some of them are equal to some other probability. Okay, so let's see what it says. The probabilities of the die landing on 1, 3, or 5 are each equal to 0.1. So that means the probability of the die landing on 1 is 0.1. The probability of the die landing on 3 is equal to 0.1 as well. And the probability of the die landing on 5 is equal to 0.1 as well. Okay, so now we don't know the probability of 2, 3, 2, 4, and 6. Okay. Then it says the probabilities of the die landing on 2 or 4 are each equal to 0.2. So that means this is equal to 0.2 and this is also equal to 0.2. Okay. Now we don't know what the probability of the die landing on 0.6 is. What does that mean? Are we in trouble? Can we work this out? 0.3 is correct. Now how did you guys work out 0.3? That's what I'm interested in. Yes, 1 minus the probabilities that are given. Okay, and why? Because the total is equal to 1. Okay, the total will always be 1 irrespective whether it's biased, unbiased, whatever. Okay, now let's see what the question is saying. Find the probability that the sum of the numbers it lands on is 9. So what does that mean? That means we have to do sample spacing. Okay, so here's 1, here's 2, here's 3, here's 4, here's 5, here's 6. Okay, let's extend this a little. And then here's, whoops, here's 1, here's 2, here's 3, here's 4, here's 5, here's 6. Okay, we want the sum to be 9. Let's see how many ways that is possible. Okay, I'm not going to fulfill the entire thing. Okay, let's just focus on where we get 9. So if we get 1 on one die, you can't get any number such that the sum is 9. Same goes for 2. But if you get 3, you can get 6 such that the sum will be 9. If you get 4 on one die, it's possible that you get 5 on the other, so that the sum turns out to be 9. It's possible that you get 5 on one die and 4 on the other. In that case, sum also turns out to be 9. It's possible that you get 6 on one and you get 3 on the other, in which case the sum also turns out to be 9. Okay, now is the answer, now think carefully before you guys say yes or no. Is the answer going to be 4 upon 36? No, why not? Why will it not be 4 upon 36? Yes, because it's a biased die. Okay? Because it's a biased die, what we will have to do is we'll have to spread this out. What do I mean by that? Here's what I mean. So we saw that we can get 3 and 6. Okay? We can get 6 and 3. Or we can also make 9 by getting 4 and 5. And we can also make 9 by getting 5 and 4. Correct? It's 3 and 6, we get 9. 6 and 3, we get 9. 4 and 5, we get 9. 5 and 4, we get 9. Okay? Now, what if I want to find out the probability of getting a 3 in the first attempt and 6 in the second? What am I going to do? How will I find out the probability of getting a 3 in the first attempt and 6 in the second? What is the probability of getting a 3? That's 0.1. What's the probability of getting a 6? That's 0.3. Okay. Then 6 and 3. 0.3 into 0.1. Or you can simply multiply it by 2. Okay, because you know it's the same die, the probabilities won't change, so you can simply multiply it by 2. Just like that, we can also make 9 by getting 4. Yes, exactly, Asya. If it's biased, there will be extra steps because now the probabilities are different. With unbiased, we don't have to worry about this because the probabilities are all equal. Okay, but when it's biased, things are different. So what's the probability of getting a 4? The probability of getting a 4 is 0.2. What's the probability of getting a 5? That's 0.1. Then just like that, the opposite will also make 9. So that means 0.1 into 0.2. Okay. Now you see how many calculations we have to do now. So my suggestion would be just use your calculator over here. And if you do it correctly, you get 0.1 as your answer. Okay. So notice that you're given plenty of space. Okay, you're given plenty. It's a 4-mark question, but look at the amount of space that you're given. Why are you given this much space? You're given this much space so that you can do your working. Probability of a dice will always remain biased? What do you mean? What do you mean? What do you mean? What do you mean always remain biased? Vijdan, can you explain your question to me, please? Because I'm not sure if I fully understand it. Okay. As you wish. All right, let's do another question. Let's do a slightly more complicated question, okay? And let's do a fairly recent question.
I
October.
have a question. When do we know that we have to draw a tree diagram on this table?
Dekho, normally when you're dealing with dice, you have to make a table. Why? Because chances are that if you're dealing with more than one, you will either have to take the sum, the product, any arithmetic operation. Okay? But if you're dealing with, let's say, different colors, or let's say winning, losing, in that case, you don't have to make a sample spacing diagram where you add or subtract. Okay? In that case, you have to make a tree diagram. Okay? So think of it this way. When it's qualitative, okay, we make a tree diagram like blue, red, green, stuff like that. But when it's quantitative, we make a table where we find the sum, difference, depending on the question. Why did we even make a sample space here? Okay, Fatma, that's a good question. You know, if you can do it without a sample space, you're very welcome to do that. Okay. In fact, you're right. We can actually do this without doing all this sample spacing. Sir, could you include what you just said in your notes? Okay. What did I say? What did I just say? Oh, when to make a tree diagram and when not to make a tree diagram? Oh, okay. That's all. So basically, this diagram is used for quantitative category of questions. Okay? Where you have to find the sum, the difference, depending on the nature of the question. Okay? A tree diagram is used when you're dealing with qualitative category, like red, blue, pass, fail, does or doesn't. You know, that's when you have to make a tree diagram. Okay? Acha, so I found a good question for you guys. It is, like I said, fairly recent question. Yeah, let's do this. The probability that, now make sure that you first read the entire question. Okay, and let me tell you something about S1. You would have some extremely lengthy question. Okay, you would have Sir, you didn't tell why. I made it because it's easier. It's easier. You can see all the numbers in front of you. That's why I made it. Okay? No other reason why. It's easier to see all the possible outcomes that way. Now, we did use it. We did use it in the sense that we at least figured out how we're going to get 9. Okay? We did use it in that sense. Okay, but now we can't do 4 upon 36 because it's not unbiased, it's biased. Okay, so we did use it partially, right? It did help us identify where we're going to get 9. Okay, does that answer your question? Okay, now the probability that a student at a large music college plays in the band is 0.6. For a student who plays in the band, the probability that she also sings in the choir is 0.3. For a student who does not play in the band, the probability that she sings in the choir is x. The probability that a randomly chosen student from the college does not sing in the choir is 0.58. Find the value of x. Okay. I'm pretty sure just by reading the question once it's not clear. Okay. But here's what we understand. We at least understand the kind of categories that we're dealing with. So what are we dealing with? We're dealing with the fact that we're dealing with the possibility that the student plays in the band and the opposite. What would be the opposite of playing in a band? Does not play in the band. That's it. We find the possibility that the student sings in the choir. What would be the opposite? That he does not sing. Okay? So when we're making a tree diagram, why is this important? So that we know how many branches our tree diagram should have. So 2 branches. Okay, one to represent playing in the band and the other to represent not playing in the band. Okay, so what is the probability that he plays in the band? It's 0.6. Now, what do you think will be the probability that he does not play in the band? Question for you guys. 0.4. That's correct. Okay. Achha. Then the question says that for a student who plays in the band, okay, so for a student who plays in the band, the probability that she also sings in the choir is 0.3. So a student who plays in the band, the probability that she also sings in the choir is 0.3. Now, what will be the probability that she does not sing in the choir? 0.7. Excellent. Okay. Now, what happens if the student does not play in the band? In that case, the probability that she sings, that she sings in the choir is x. Now, what will be the probability that she does not sing in the choir? Now we're in trouble. 1 minus x. That's correct. Okay, so just like what we did over here, we're doing the same thing here. Only difference is that we're subtracting x from 1 and we get the answer in terms of x. Okay, now once again, if you made this tree diagram correctly, there's no one that can stop you from doing the first part correctly as well. Okay, and the second part as well for that matter. Now, how do we do the first part? For that, this is the key piece of information. This is, you can say, the missing piece of the puzzle. The probability that a randomly chosen student from the college does not sing in the choir is 0.58. Okay? So the probability that the student who is randomly chosen does not sing in the choir is 0.58. Okay. Now, don't worry about what the question, what the individual probabilities are. Just tell me, how many ways can we fulfill the condition? 2 ways. Okay. Tell me, what are those 2 ways? What are those 2 ways? Band. Okay. By the way, it's no choir. Okay. Band and no choir. Just like that. No band, no choir. Why? Because the question says the probability that a randomly chosen student from the college does not sing in the choir. So that means it's possible that that randomly chosen student is in the band but not in the choir. So band and no choir. Or it's also possible that that randomly chosen student is not in the band and not in the choir as well. So that means 0.4 into 1 minus x. This is also possible. And this is equal to what? This is equal to 0.58. Now, anybody can solve this and get the value of x. That's not what's important right now. Tell me if you guys understand what I've done here.
Could you please give an overview again?
Okay, I will. So the question says the probability that a randomly chosen student from the college does not sing in the choir is 0.58. Okay. Now, what does it say about the band? What does it say about the band? Does it say anything?
No.
It doesn't. What does that mean? That means the student could be in the band, or the same student could also not be in the band. Okay?
Yes.
Okay. We have to focus on the fact that the student does not sing in the choir. Okay? It's like, think of it this way. It's like the question says, find the probability that the second one is blue. That means the first one could be red, the second could be blue, the first one could be blue, the second could also be blue, the first could be green, the second could be blue. Okay, so we only have to focus on the student not being in the choir. So it's possible that that student is in the band but not in the choir, or it's also possible. Acha, wait, I should have written this instead of straight away writing the probability. It's also possible that the student is not in the band and also not in the choir, which is equal to what? Which is equal to 0.58. Okay, does that make sense now?
Yes, sir.
Okay. Now, band and no choir, the probability 0.6 into 0.7 plus no band. Yeah.
So why would that be equal to 0.58?
Because the question says so. Where did the 0.58 come from? It came from the question. You thought I worked it out.
It comes from the question, but I heard that its second bracket will be equal to 0.58, like only the second bracket.
No. The entire sum will be equal to 0.58. Why? Because this is representing band and no choir. This is representing no band and no choir. What's common in both? No choir. Because the question says that we're only told about the fact that this college that the student does not sing in the choir. That means that student could be in the band but not in choir, could not be in the band but and not in the choir. So we have to consider both possibilities. Just like if you go back to this example, if the question said that the first is red and the second is green, we considered just the possibility that first is red and the second is green. But if the question said one is red and the other is green, the question did not tell us which one is red, which one is green. So what did we do? We considered both the possibilities. Okay? That first being red and the other being blue, and first being red, the other green, and green red as well. So just like that, since the question hasn't told us whether or not the student should be in the band or out of the band, we consider both. Okay, does that answer your question?
Yes,
Okay.
sir.
All right, now if you solve this, you get 0.6 as your answer. Okay, now that you have the value of x, a good idea would be to replace x with 0.6 and here replace it with 0.4. Okay? Acha. Here the question says, now there is a part B. Two students from the college are chosen at random. In fact, you know what? I'll just let this be x and 1 minus x so that later on when you guys are revising, you're not wondering.
Sir, I had a question.
Yeah, go ahead.
Just since the question states, could you please like scroll up a bit?
Just a
Since
minute.
the question,
Just a minute. 0.6, 0.4. Yeah, हाँ बोलो.
since the question here says that a probability of randomly chosen student from the college does not sing in the choir, so we won't be considering the probability of a student who's part of the choir, like, right?
No, we're not.
This case where we do not consider 0.3
Yeah.
and x. Okay.
Yeah. देखो, just think of it this way. How many ways is it possible that the student does not sing in the choir? Just think of it this way. How many ways?
That he's part of the band and then he's not part of the band.
Exactly. He's part of the band, not part of the choir. He's not part of the band, also not part of the choir. That is why we're considering both. Okay?
Right.
If the question said that the probability that the student chosen randomly is neither part of the band nor part of the choir is so and so, in that case हम क्या करते हैं?
Could you please repeat the question?
Let's say the question said that the probability that a randomly chosen student from the college does not sing in either the band or the choir. In that case हम क्या करते हैं? Do you understand my question?
Let's say the particular
Hmm.
and not choir.
That's it. Okay. But here, since the question hasn't told us whether the student is in the band or not in the band, so we have to consider both the possibilities. Okay, we have to consider all the possibilities in which a college student does not sing in the choir. Okay.
Right, sir. Okay.
All right. Acha, अब let's do part B. Two students from the college are chosen at random. Find the probability that both students play in the band and both sing in the choir. Okay. Now, this is a question that anyone can solve. So, both students play in the band and both students play uh, in the choir. So, how do we do this? बताएं. Both students play in the band. Acha, by the way, let me tell you, you don't actually need um, the tree diagram for this. I don't know why I drew it. You don't need the tree diagram for this one. So both students play in the band. The probability of that would be both students play in the band and both sing in the choir. So it's possible that in one way, student is part of the band and part of the choir, or what's the other possibility?
Not part of the band.
No. Read the question. Read the question. Find the probability that both students play in the band and both sing in the choir. So the other order, C and B. So you've chosen two students. You want to find out the probability that both students play in the band and both sing in the choir. Okay. So one way to fulfill this condition is that the first student chosen is part of the band. Yeah, you can do that. You can simply multiply it by 2 as well. And the second student is part of the choir. Or it's possible that the first student is the one who sings in the choir and the second one is the one who's part of the band. Okay, or you can simply find out the probability of 1 and multiply it by 2. Okay, so let's work this out, see what do we get. 0.6 into 0.3 plus 0. Yes, it is, which is why you require a bit of practice and then eventually you get the hang of it. 0.3 into 0.6. Okay, now. Acha. See if you guys can answer this. Sir, for C, won't we do both cases? What do you mean? What do you mean? For C, won't we do both cases? But did the student not ask about both the students being in the band and both? No, एक second. First, let me answer Mustafa's question, then I'll answer your question, Intishar. Like, a band and choir, not band and choir. But it says find the probability that both students play in the band and both students play in the choir. Acha, वैसे, by the way, 0.6 into 0.3 is correct and 0.3 into 0.6 is also correct. But there is one small problem in this. And 0.36, by the way, is not the final answer. There's one small problem, which if you read the question, you'll be able to identify what that problem is. Read the question. I'll give you guys a minute to figure it out.
So we're not considering like DD and CC, like both are part of the band and then both are part of the choir.
ठीक है, ये भी कर सकते हैं. Yes, we multiply. We don't add them. Okay, we multiply them. We don't add them. Why is that? Read the question. You'll find the answer. Yes, so the question says and. Okay, the question says and. Both are part of the band and both sing the choir. Okay, so both are part of the band and both sing the choir. Achha, by the way, for those of you who are saying कि हम इसको ऐसे कर लें, that band and band, okay, into choir and choir. This is also correct. Okay, this is also correct because ultimately, if you look at the working is the same. Acha, how? I'll explain. So first, let's work this out. See what we get. 0.6 into 0.3 into, or we can just square it. We get 0.06 0.324. ठीक है. अब देखो, here's another way to think about it. Two students from the college are chosen at random. Find the probability that both students play in the band and both sing in the choir. So, since we're multiplying, yeah, exactly. Since we're multiplying B and C and then we're multiplying that with C and B, doesn't matter if we do B and B and then we multiply it by C and C. So, if you do band and band, which means 0.6 into 0.6 into 0.3 into 0.3, that's also acceptable. Okay, so one student, because here it's not like with or without replacement. The probability remains the same, irrespective whether it's the first student, second student, third student, fourth student, does not make a difference. Okay, so here also, if you work this out, you get the same answer. Yes.
So only because this is multiplication, so the order really doesn't matter. But
Yeah.
is it right to say this B and B?
Yeah, you can do that. Both students play in the band and both students play in the choir. You can do that. Dekho, if both students play in the band, what does that mean? That means band and band. And both students play in the choir, what does that mean? That means choir and choir. Okay? Does that answer your question?
Yes, sir.
Okay. Acha, let's do another question. Another question very similar to this, and this is also a very recent question. So, how about you guys try this? How about you guys try this? Remember to make a tree diagram. Please don't be lazy about it. Okay? Don't duck your way into solving this question by avoiding a tree diagram. It's not going to help. Okay? You'll only increase your chances of getting the question wrong. 0.22 is the correct answer. Okay, so I'll quickly solve this question and maybe we will have enough time left to solve another one. Okay. On each day that Alexa goes to work, the probabilities that she travels by bus, train, or by car. So, how many different categories do we have? We have three different categories: bus, train, and car. Okay. And then after that, what happens when she travels by bus? What happens after she travels by train? What happens after she travels by car? She can either be late or not be late. Okay. So what's the probability that she travels by bus? That's 0.4. In fact, let's write it like this. Let's write bus here, train here, and car here. Okay. So 0.4, 0.35, and 0.25. Now, if she travels by bus, there are two possible outcomes. Okay. One is that she is late, and the other is that she is not late. The probability that she travels by bus and she arrives late is 0.45. So late and not late. So that's 0.55. Now, what will be the probability of not late? That's going to be 0.45. The probability that she travels by train and she arrives late is 0.7. Okay, so what will be the probability that she is not late? 0.3. Good job. The probability that she travels by car and she is late is x. So what will be the probability that she is not late? 1 minus x. Good job. Late, not late. Once, like I said, once you've done this correctly, chances are everything else will fall into place. On a randomly chosen day when Alexa goes to work, the probability that she does not arrive late. So, how many ways can she not be late? She can travel by bus and not be late. She can travel by train and not be late. She can travel by car and not be late. Okay. So, a good idea would be to write this down: bus not late, or train and not late, or car and not late. So the probability that she travels by bus is 0.4. The probability that she is not late is 0.45. The probability that she travels by train and then the probability that she is not late is 0.3. Then the probability that she travels by car is 0.25. Then the probability that she is not late is 1 minus x, which according to the question is equal to 0.48. Now, after doing a lot of simplification, a lot of calculation, you will get the correct answer, which is 0.22. Okay, now there is a second part to this question which we're going to skip for now because this is conditional probability. Okay, so we're going to skip this now. Inshallah, in the next class, when we do conditional probability, we'll do this. In the meantime, I will still like us to do another question. Okay, do this one. Last question of today's class. And this worksheet, by the way, contains nearly all types of questions that we can solve. I will further highlight all the questions that you guys can solve comfortably. Okay, so just make sure that you guys do that. Okay. Yeah, for now, I would like you guys to solve this question. 0.25. All right. Let me check. This is from October, November 2019. 0.25 is correct. Good job. Okay, so does anyone want me to solve this? Yes, no? All right. So once again, take care, everyone. Allah Hafiz.